We'll just keep repeating it. Here we go with adding extra stuff. X minus h squared plus y minus k squared equals r squared. Soon you'll see an A along the bottom. We grab the circle, and I think we start with this. 1 and 0, 0 and 1. Click here, realizing these are pi over 4, pi over 3, pi over 6, over comma, 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 over 2, over 2, over 2, over 2, over 2, over 2. 1, 2, 3. 1, 2, 3. Think of a waltz if you must. Square root of 2, square root of 3, square root of 1 is 1, square root of 2, square root of 3. Know that on another circle or the same circle or whatever, that this over this times this equals this. This is the tangent. This is the sine. This is the cosine. This is 1 in a unit circle, not a 1 in all circles. That's the cotangent. This here is the cosecant. And this distance here, all the way out, is the secant. Again, from the juicer, if we go from 0 to pi to 2 pi, same thing around the circle here. You know that the sine of 0 is, oh, there's the sine. Sine of 0 is 0. Sine of pi over 2 is 1. And the sine curves like that. And then for the cosine, you're just going to shift this over by pi over 2, and it does something like this. And this is then a harder one to draw. This is the cosine. This is the sine. Tangent you'll later see. The tangent of 0 is 0. The tangent of 45, or pi over 4, is 1. So this does something like this and then up. Right? Come up out of there. It kind of goes up and over. Or something like this. Up to infinity and back. Alright, so cosine, sine. We remember small angle approximations. We know that the tangent of 0, of theta, when theta is small, equals theta. And we know that the tangent is sine over cosine. We know that the cosine of theta when theta is small, small angle. Cosine of theta when theta is small is equal to 1. That makes sense here. And then the sine of theta when theta is small is equal to theta as well, because sine equals tangent when the angle is small. 1, 2, 3, 4. Again, the last time, I think one of the other ones you have is to draw a big circle. Once again, pick a point. Usually picking that 1 radian point's not a bad one here. You've got that there. You know that this is theta. That's theta over 2. And this becomes 2 theta. You can get a lot of things out of that. I believe that in essence that is all of the unit circle, and there's no reason to not be able to do that and then start putting things out like sine squared plus cosine squared equals 1, and then start deriving other things off of that circle. So in 5 minutes this was the general form of a circle. We'll put one more. Form of a circle in the polar format. R equals some value. R equals 5 is the other form of a circle. That's a form of a circle. That's a form of a circle written out in mathematics. One is in Cartesian, one is in polar. 0 and 1, 1 and 0. Over 2, over 2, over 2, over 2, over 2, over 2, 1, 2, 3, 1, 2, 3, square roots of the tops, and you have in effect what is the the cosine and the sine, the cosine and the sine. You have the picture that you all have already. You have the waves, which many of you learned the first way. Remember, they are out of phase by pi over 2 or 90 degrees. Sine begins at 0 and cosine begins at 1. They're out of phase by pi over 2 or 90 degrees. You have the small angle approximations, and that gets you a lot. Thanks for listening.